Good afternoon, everyone. So, in the previous class, we have seen about learning set of rules. Okay. So here, learning set of rules is nothing but we can learn set of rules by using different techniques like ID3, C4.5. So all these things. So this we have used in the case of decision tree. In the same way, here also we will be using different techniques like sequential covering algorithm, foil. Okay, so all these things are different types of techniques which we will be using. Which we will use here. Okay. So here we can learn set of rules by using ID3 and then covering the tree to rules. So what we will do, we will just first write the rules and then we convert this into tree in a particular algorithm that is called as decision tree. So if you see in the case of genetic algorithm, we can also use genetic algorithm that encodes the rules at bit strings. So there we will be using bit strings. With bit strings, we will be generating the rules. Then we apply different types of operators like select operator. Okay. Next crossover operator, then mutation to get the result. But these only work with predicate rules, with no variables. Okay. So these work when no variables are there while forming the rules. But here, in case of learning set of rules, we will be using different variables to frame the rules here. So they also consider the set of rules as a whole, not only rule at a time. So here, one by one, we will not consider all the rules at a time. Just what we do, first we consider one rule and we generate the hypothesis. Again, we generate one more rule which is connected to the before one. Then we generate the result. So likewise. So this is in case of learning rule. So here you can see what are the rules, how we are going to generate. A rule set can look like. So how it look like if parent of x comma y, then ancestor of x comma y. If parent of x comma z and ancestor of z comma y, then ancestor of x comma y. So here what we are doing, parent of x comma y is a predicate. That is something that we are predicting, which indicates that y is the parent of x. Okay. So here these two rules, which two rules? These two rules. So these two rules form a recursive function. So these form relation between these two. Okay. Which would be very hard to represent using a decision tree or propositional representation. So this cannot be done in case of decision tree or genetic algorithm. This can be possible only by using sequential covering algorithm or learning first order rules. So in this case, we can use recursive function, but not in the case of decision tree and genetic algorithm. So this is the difference between those algorithms and this algorithm. We can view the learning of rules and the learning of prolog programs. Now, we have seen this sequential covering. So first, we will take target attribute and attributes examples and we give one threshold point. Then the learning rules will be at empty space. Okay. Then we learn the rule. While that performance, that particular rule is greater than threshold, one rule is generated. So likewise, we will be using for all the examples. Okay, so this is sequential covering algorithm. So if you see here in sequential learning algorithm, I'll give you one example. So the particular algorithm which we use here is sequential covering algorithm. So this uses disjunctive set of rules. Okay. So what is disjunctive? Disjunctive is nothing but there won't be any connection between different rules. Rule ki inko rule ki connection undadu. Okay. Just we will frame the rules here. Okay. So here conjunctive rules ante oka rule ki inko rule ki difference untadi. I mean connection. Example enti ante conjunctive rule example enti ante if you wake up at 6 a.m. you can get breakfast. And again this can be written as if you had breakfast. If you have breakfast, you can work more. Have connection. So this is conjunctive. And I made breakfast tinte 6 ki leste breakfast tinte. With breakfast tinte manchiga work chestam. Okay. But in case of disjunctive, okay. In case of disjunctive rules, example is if you deposit money in bank, you get 2%. Okay, input Indian if you deposit money as FD, you get 5%. So these are the two rules you are having. So there is no connection, no need of having another rule. Okay, so this is disjunctive. So in this way, what we will do is we will frame different types of rules. Okay, so here mainly in sequential covering algorithm, we will be using disjunctive rules. So that is about sequential covering algorithm. Next is learn one rule. Learn one rule idea is nothing but organize the hypothesis-based search in general to specific fashion. Starts with most general rule. So we will apply a particular rule. General rule is generated, that is precondition. With precondition, one general rule is generated. We start with that. Then what we do, we greedily add some attributes to that particular rule and we generate other rules, which we apply to all the examples which are there in the data set. So this is nothing but learn one rule. Oka rule నేర్చుకున్నాం అనుకోండి, ఆ రూల్ నుంచి మనం స్టార్ట్ అవుతాం. ఇంకో రూల్ ఎట్లా ఫ్రేమ్ చేయాలి, ఇంకో రూల్ ఎట్లా ఫ్రేమ్ చేయాలి, అన్ని ఎగ్జాంపుల్స్ ని ఇంక్లూడ్ చేసుకుంటాం. సో దట్ ఈస్ లెర్న్ వన్ రూల్. ఓకే. So here you can see, learn one rule is nothing but general to specific search. So this is one more type of algorithm which we use. Okay, it is greedy depth first search method. There will be no backtracking. It begins with most general rule. Okay, and then what it will do, it greedily add the attribute test. So on different attributes, it goes on generating the rules here. It is high accuracy and incomplete coverage. So this is learn one rule. So what we are doing, if then play tennis is equal to yes. Okay. So what will happen from this rule? This is general rule. From this, we go on adding the attributes and generate the rules here. So if weak is equal to wind is equal to weak, then play tennis is equal to yes. So this is dependent on this. If wind is equal to strong, then play tennis is equal to strong. So like this, we are going to generate different types of rules. Okay. So the aim of all these things is nothing but for framing the rules. Okay. So first we frame the rules and then we generate the decision tree. With that we get the result or solution. Okay. So learn one rule algorithm is this. Okay, just by heart. And here one example is given. So this is the data set which we have taken: day, outlook, temperature. Day, outlook, temperature, humidity, wind, play tennis. So this is the data set which we are having. Now what we are doing, we are generating the rules for this. Okay. So for getting the best hypothesis, if then play tennis of x is equal to yes, then candidate hypothesis will be best hypothesis. Okay. So what we are doing, all constraints with, we are generating the rules here. All constraints with all conditions. We are applying all conditions here. Outlook of x is equal to sunny, outlook of x is equal to overcast, temperature of x is equal to hot. So likewise we are considering all the conditions. Okay. Now if outlook is equal to sunny, then play tennis is equal to yes. If outlook is equal to overcast, then play tennis is equal to yes. So likewise we are generating different types of rules with this particular data set. Okay. So here it can be generalized to multi-valued target function. Multi-valued target function is given two outputs. To a particular variable, you will be having two outputs. So here there are other ways to define performance besides using entropy. So in the case of decision tree, we have used entropy. In the same way, we will be using performance here. Okay. So I'll show you one example here. See here. This is the data set here we are having. So what is it? We are just learning the rule list here. Okay. So in terms of the data set, this is data set. Now what we are doing here? Initially, all in this particular learn one rule algorithm, initially all the instances are considered. Any instances we can consider chestamu. Okay. Then we define a rule such that most of the instances have to be eliminated. How to be eliminated? So if we consider any particular rule, if that rule is generated, then what we have to do, we have to eliminate the instances here. Okay. So our aim is to consider all the positive instances and we have to eliminate all the negative instances. So with that only we will be getting the best solution. So here next what we have to do, which literal is to be considered. Literal and a attribute ni మనం consider cheyali. So in the case of decision tree, I have told you how to consider the root node. Root node ని బెస్ట్ నోడ్ గా ఎట్లా డిసైడ్ చేయాలి అనేది మనకి డిఫరెంట్ అల్గోరిథమ్స్ ఏంటి ID3 కానీ C4.5 కానీ. So this will decide which particular node should be the root. In the same way, here also which literal is to be considered and how to find the root here. So this we have to keep in mind. Okay. Now take the first rule. So what is the first rule here? I have considered one rule. If gils is equal to yes, then class is equal to negative. Okay, so this is my rule. I am framing this rule first. So my first rule is this. That is, if gils is equal to yes, then class is equal to negative. So when this particular rule is applied, what we have to do? We have to reduce the instances. So we have to eliminate some instances which are not required. Okay. So now consider this rule. Decide to this what you have to do. We have to apply for all the instances. Okay. So if you see here on the right hand side, length is equal to 3. So how I have written 2 plus 0 minus. So that I will tell you. If length is equal to 3, how many instances are there? So if you see here, these are all positive instances and these are all negative instances. So 5 positive instances we are having and 5 negative instances. So that I have written here. Okay. So now consider length is equal to 3. So length is equal to 3, 2 plus 0 minus. So what is this? Okay. So if you see here, length is equal to 3. How many are there? 2. Okay. So 2 positive instances are there with length is equal to 3. So that I have written 2 plus. So in the negative examples, just check whether length is equal to 3 are there or not. So length is equal to 3 is not available in negative instance. So what I have written? I have written 0, negative. So there are no negative examples with length is equal to 3. So in the same way, length is equal to 4. So if you check in the positive values, positive instances, length is equal to 4, we are having 1. So I have written 1 plus. Check in the negative side, 3 minus I have written. So length is equal to 4, 1, length is equal to 4, 2, length is equal to 4, 3. Okay. So that is 3 negative. So that I have written. In similar way, I have written all these values. Okay. So for 5 positive and 5 negative. Now, what you have to do? Consider this rule. That is, if gils is equal to yes, then class is equal to negative. Okay. Consider this rule with length is equal to 3. If length is equal to 3, gils is equal to yes, then you have to eliminate that instance. Okay. So then you will get 2 plus 0 minus. How you will get 2 plus 0 minus means gils yes undi, length is equal to 3 unte into chudandi, length is equal to 3 and gils is equal to no. Idi manam consider cheyali. Length is equal to 3, gils is equal to no. Idi manam consider cheyali. So these two we will consider. So what I have written? 2 plus. In the same way, gils is equal to yes, length is equal to 3. Just so there is no gils is equal to yes and length is equal to 3. It is not satisfying the condition. So I have written 0 minus. Okay. Now check with second instance. Length is equal to 4. Okay. So length is equal to 4 and gils is equal to yes. Length is equal to 4, gils is equal to no. So this you have to consider. Endukante manaki gils is equal to yes anedi unte consider cheyoddu. Gils is equal to no anunte consider cheyali. అని మన condition we have specified here. Okay, so in the same way 1 plus 1 minus you will get. So you have to check for all the other conditions also with comparing with this particular rule. Okay, then you will get this output. Next, what I did, I have written one more rule. If teeth is equal to many, then class is positive. Teeth many unti, class దాన్ని ఏం చేయాలి, పాజిటివ్ ఉంటే అవిటిని కన్సిడర్ చేయొద్దు అని నేను అన్నాను. ఓకే, సో వాట్ విల్ హ్యాపెన్, దెన్ ఐ గెట్ these out. So in the same way, likewise, we will be eliminating the negative examples here. Okay, so ఈ particular rule ని మాత్రమే నేను ఎందుకు రాశాను అంటే, you have to consider the values, negative values. So negative value ఏంటంటే జీరో నెగిటివ్ అనేది ఏదైతే ఉందో ఆ పర్టిక్యులర్ వేరియబుల్ ని మనం కన్సిడర్ చేయాలి. సో ఇక్కడ జీరో నెగిటివ్ అనేది టీ ఈజ్ ఈక్వల్ టు మెనీ ఉంది. నెక్స్ట్ జీరో నెగిటివ్ అనేది లెంత్ ఈజ్ ఈక్వల్ టు 5 అని. సో దీస్ టూ ఇన్ ది by using these two you can frame one rule. Okay, so likewise you have to generate different types of rules. So this is called as rule list. So you are learning the rule list here. Then you will be generating the decision tree. So for these rules, this is the decision tree. After eliminating the negative values, this is your output you are getting. Okay, so this is about learning rule list. So next is learning first order rule. This is also called as foil. Okay, so this type of this program or algorithm, it is similar to sequential covering algorithm. So this is also similar to sequential covering algorithm. So here what we are going to do is one by one rules will be learned. How we are going to learn one by one rule by using sequential covering algorithm. The same way we will be using different rules here by using this particular technique also. Okay, and here it provides different types of set of rules, and this is extension of learn one rule algorithm. Okay, so what we are doing here is basically it is used to learn first order rule. That is nothing but it is used to learn on class rules. On class rules ante ఒకదానికొకటి ఎట్లా లింక్ అప్ అయ్యింది. Okay, so those are called as on class rules. And here in foil you will be having two loops are provided. One is two loops are provided. One is outer loop and another one is inner loop. Okay, and here in outer loop it works just like sequential covering algorithm. Sequential covering algorithm ఎట్లా వర్క్ చేస్తాం, మనం ఒక్కొక్క రూల్ ఫస్ట్ ఎంటీ తీసుకుంటాం. సో యూ కెన్ సీ హియర్ learn rules is empty. Okay, rule is learned at a time. One rule is learned at a time. Okay, learned rule examples will be deleted. Rule generate అయిపోయినాక ఆ రూల్ ఏ ఎగ్జాంపుల్స్ అయితే మనం జనరేట్ చేసామో ఆ రూల్స్ అన్నింటినీ మనం రిమూవ్ చేస్తాము. దెన్ అగైన్ we learn next rule. Okay, so that is in case of outer loop. So this is outer loop. Now this is our inner loop. Now in inner loop it just works like learn one rule. Okay, so ఇంతకుముందు మనం learn one rule చూసాం కదా, సేమ్ యాజ్ ఇట్ ఈస్ గా it is also works. So this is a combination of sequential covering algorithm and learn one rule algorithm. So these two will be combined to form first order rules. Learning first order rules. Okay. So what you are going to do? Learn a new rule. So here what it is going to do is it learns the rule to which the training example's target concept is true. True ఉన్న వాటిని మాత్రమే కన్సిడర్ చేసుకుంటూ రూల్ జనరేట్ చేస్తుంది. ఓకే, అండ్ ఇట్ ఫాలోస్ సర్చ్ algorithm. So that is called as hill climbing search. So here hill climbing search ఒకదాన్ని ఒకటి ఎక్కుకుంటూ ఎట్లయితే మనకు టాప్ పొజిషన్కి చేరుకుంటాము అట్లాగే we will be removing all the negative examples and we will be adding to the negative examples. With that positive examples, to that we will be generating the rules. Okay, so here hill climbing search method technique is used in foil. So what it will do? New rule, the rule that predicts target predicted with no preconditions. So there won't be any preconditions before. It cannot. It will not give any condition. Just it generate a rule. Okay. So here to eliminate the negative instances, new rule negative, then negative. Then you have to eliminate that. By creating that rule, you will be eliminating the negative instances. Okay. Add a new literal to specialize to new rule. What is literal? Literal is nothing but a particular attribute. Okay. So see here. First order inductive learning. So foil. So in first order logic, what all the expressions in first order logic are composed of the following attributes are: you will be having constants, you will be having variables, you will be having predicted symbols, you will have function symbols, you will have connectives, you will have quantifiers. Okay, so constants you can see here Tyler 23A. So like this we will be using. Variables are A, B, C, likewise. Predicate symbols are nothing but male, father, so like this. Okay, and the different function symbols, that is nothing but age is one of the function symbol which you will be using. Connectivities is nothing but this is used for and, this is used for or, this is used for conjunctive. Okay, it tends to, not tends to. And quantifiers like for all, does not belong to, so likewise. So term, it can define as any constant, variable or function applied to any term like age of Bob. So likewise. Okay, here is one example I'll show you. Can be given positive later. Okay. So H is nothing but hypothesis, B is nothing but or, not L1 or so on, not Ln, so likewise. So you will be defining the rule in this way. So here you can see example: A or not B. Okay, so that can be written in this way. So you will be framing the rules in this way. So here you see this particular function is read as if B then A. So this is called as inductive logic. Okay, and you can see here this symbol is used for conjunction. This symbol is used for OR. Okay, this is logical NOT. So here is one example. So what is the example? 85% of the humans are like football. John is human. That even we want the output conclusion mostly. John likes football. Okay. So one more example in here. 85% of the students qualified in exam. Raju is a student. Ante ఏంటి అంటే those 85% who have attended the exam have cleared the exam అన్నట్టు. అంటే Raju attended exam, Krishna not attended the exam. అంటే Raju exam రాసాడు, క్లియర్ అయ్యారు. Kiran not attended exam అంటే క్లియర్ అవ్వలేదు అని అర్థం. Okay, so in this way we will frame the rules. So here one example. If any, then GD of x comma y. Is it positive or negative? Okay, so positive Indian. So yes, no. So S is nothing but fathers. X are somewhat likely to be grandfathers. If father is z comma x, then GD of x comma y, granddaughter of x comma y. So in this way we will be framing the rules. Okay. Example again, one more example. If any student attended the exam, that is nothing but he or she cleared exam. Then you can if attendance is equal to y, then result is equal to pass. So whatever the frames, whatever the rules which we will frame in the same way, it is generated. So you can see here, step 1, new rule ఏంటి, granddaughter x comma y. So ikkada granddaughter x comma y, the root node. Okay, generate the candidate literals. What is that? Female x, female y, father x comma y, father y comma x, father x comma z, father z comma x. So these are all different types of literals that you have to generate here. Okay, that you have to generate here. So likewise you will be framing different types of rules by using different types of algorithms. One is the sequential covering algorithm, one more is learn one rule algorithm, another one is first order learning algorithm, inductive learning algorithm. Okay. So introduction, sequential covering algorithm, learning rules and summary, learning first order rules, in this we have finished, learning set of first order rules, foil, this we have finished, induction as inverted deduction. So induction as inverted direction. So this is second approach to inductive logic programming. So this is one of logic programming which we use here. Okay. It is based on the assumption that induction is the inverse of deduction. So here see more formally, induction is finding a hypothesis. So we are finding one hypothesis H. That is nothing but we are finding some output such that it can be written as for every xi and any instances f of xi is a target concept that belongs to D and a data set. B is nothing but background knowledge, which will have some background knowledge, okay, or hypothesis or x of n. Then it is not f of x of m. Okay. So to see here one example is given. So this is one example. Pairs of people u comma v such that child of u is v. This is concept. Suppose we are given one training example. This concept is one training example which is describing two people. Who are those two people? Tim and Sharon. In terms of their gender and their relation in terms of predicate father. Okay. Data set lo ee names unnai. Father relation వాళ్ళతో ఏంటిది అని కూడా ఉంది. దాంట్లో ఎవరు మేల్ ఎవరు ఫీమేల్ అని ఉంది data set lo. Okay. And giving the target predicate child Tim comma Sharon for these two people. So మనం ఏం predict చేస్తున్నాము? Child Tim. Sorry. Sharon is child of Tim. Okay. Sharon is child of Tim. Okay. So this is our prediction. Now background knowledge asserting that if U is the father of V, then U is the father of V, parent of V. So how we are going to write that? So f of x ఏంటి ఇక్కడ మన టార్గెట్ కాన్సెప్ట్ ఏంటి? చైల్డ్ టిమ్ కామా శరణ్ అంటే శరణ్ is child of Tim. So this is our prediction. This is our target concept. So here Tim is male, female is Sharon, father is Tim. Tim is father of Sharon. Okay, so this we have predicted. Parent U comma V. That can be written as father U comma V. Now, what H satisfies? So this is our formula. What is this? So that can be written as H1 and hypothesis 1. Hypothesis 1 is chain U comma V is nothing but father V comma U. Okay. Chain U comma V is nothing but parent V comma U. And U is parent of V. U is parent of V. V is child of U. Okay. So H1 ఏంటి? H1 father Sharon comma Tim. Child Tim comma Sharon. So in the two ways you can write it. Okay. So parent U comma V, that is nothing but father U comma V, or H2 or father Sharon comma Tim. So in all these ways you can write this particular rule. So this is called as inductive rule. So this is called as inductive learning. So in different ways we can describe the rule here. We'll be having positives and negatives both. Okay. So what are positives here? Early idea of finding H that fits the training data. It will find the hypothesis which fits for the training data. This is positive one. Domain theory B. B is nothing but background, which helps define meaning of fit the data. So previous data, ఆ particular data కి ఎట్లా ఫిట్ అవుతుంది, ఆ రూల్ ఎట్లా ఫిట్ అవుతుంది. So that is done here by using inductive learning theory. It suggests that H guided by B. So by background theory only we can get the hypothesis. And what are the negatives? Negatives are nothing but does not naturally allow noisy data. Noisy data any allow cheyadu. Okay, and there is overfitting, impossibility of calculating all the acceptables of hypothesis. So we cannot trace all the hypotheses for all negative values. Okay, so this is negative. And there is propositional resolution. So what is propositional resolution? So operator O, B and the background, D and the data, that is equal to H, where for every instance a target function that belongs to D, background or hypothesis or x of I, it tends to target concept, then that is equal to O of B, D. So propositional resolution is nothing but it is contradictory to inductive learning here. Okay, so let's show you one example. So here you can see C1 and C2. C1 and C2. Resolvent is P or R. అంటే ఏంటి అని అంటే C1 అంటే క్లాస్ 1, C2 అంటే కాన్సెప్ట్ 1, C2 అంటే కాన్సెప్ట్ 2. కాన్సెప్ట్ 1 ఏంటి అని అంటే I tell you one example. If practice win game. C2 అంటే ఏంటి అంటే losing game because less practice. So in this way we have to frame the rules here. So see, this is the example. So this is inverted propositional resolution. So study, no material. If you know material, you can study. If you pass exam, that is nothing but you know the material. Okay, so this is positive one. Now if you see here, if you know material and you will not, if you know material also you will not study. Okay, if you pass the exam also, you don't know the material. At last what is happening here? You will pass the exam but you will not study. So this is nothing but inverted propositional resolution. So from these rules only we will be framing the contradictory part. The right side is the contradictory part to the left hand side rules. So that is nothing but inverted propositional resolution. So with this 4 units, second part is completed. In next class we will start the reinforcement learning. Guys, it is very tough subject. If you read only, you will understand. Just practice all the rules, all the formulas in your home. Okay. And I'll tell you how to read the chapters in what way. Okay. On Saturday, I'll explain it. I'll tell you. So on Saturday, we'll finish up the fourth unit and we'll start the fifth unit. Guys, sign up. Are you there? Just send me the attendance. Guys, one thing. Guys, one thing. Here, everybody is focusing on your attendance. Okay, just concentrate on your attendance. All of you attend the classes regularly from today onwards. Why? Because they will be seeing these days only. Why? Because from the next week onwards, I think you are having your lab. Okay. So tell your friends to attend the classes regularly from today onwards, at least from tomorrow onwards. Okay. So after that, what will happen? We don't know. Okay, tell your friends to attend the classes regularly. Attendance is very serious thing. Okay. Yeah, okay, you can leave.